In this video, we're going to look at how to set this problem up in Excel. And the example is customer arrivals in a food market. And we are looking at number of customers arriving in the store in a 5-minute interval. And we have data already gathered. The sample has 128 5-minute intervals. And how many customers arrived in each of those 5-minute intervals is summarized here in this table. So we start with this table. First, the population. The number of customers entering the store during a 5-minute interval. The null hypothesis is the number of customers entering the store during 5-minute interval has a Poisson probability distribution. And the alternative is that it does not have a Poisson probability distribution. Okay, we'll use an alpha value of 5%. Okay. Now the sample size is, we already have the data arranged here. If you sum all the frequencies, that will give us the sample size. So the sample size is that. Now X bar is that we have to compute a weighted average. So we start with sum product of the X values, comma, the corresponding frequencies as the weights. And then we have to divide by the sum of the weights, which is the sum of the frequencies. So that gives us the X bar. Now we can use this X bar in the Poisson.dist function to find the Poisson probability. Poisson.dist for x equal to 0, comma, X bar from that cell, and that should be absolute referenced. And then you have to include 0 for non-cumulative individual probabilities. Now copy this. Okay. And then let's put the border back. Now we have to sum the probability and see whether the sum is equal to 1. If the sum is not equal to 1, then you have to make sure that the last probability is set to 1 minus the sum of the rest of them, so that the probabilities do sum to 1. Now the expected frequencies are the sample size times the probability. And when you sum the expected frequencies, it should equal the sample size, which is correct. Now these two expected frequencies are less than 5, so we need to combine the two. So the frequency will be that plus that. And the rest are exactly the sum of the two. Then the next value, starting from 2, okay, is exactly like in this table, because they are all, the expected frequencies are all greater than or equal to 5. So now the revised table, in which all the expected frequencies are greater than or equal to 5, is what we have to use to find the chi-squared. So chi-squared is observed frequency minus expected frequency squared divided by the expected frequency. Now we Copy that. Add that. And that's our chi-squared value. Let's put the border back here. Now K is, we'll use count A from the revised table. That gives us the number of categories. Now degrees of freedom for Poisson goodness of fit test is K minus 2. And the p-value is chi-squared dot dis dot rt, the chi-squared test statistic value, and then the degrees of freedom. So the p-value is 14%. Now conclusion then is, since p-value is greater than 5%, we do not reject the null hypothesis. And then the interpretation is, we do not have sufficient evidence to conclude that the number of customer arrivals in a 5-minute interval is not Poisson distribution. We can't say that. So we have to agree that it is Poisson. If we concluded that it was not Poisson distribution, then the probability that the conclusion is wrong is 14%.